You ever look at how money moves and wonder why some things grow in a nice straight line while other things just seem to explode? Well, it's not random. It's not magic. There's a hidden math behind it all, and today we're going to crack that code.
So let's just get right into the big question. Is there a real predictable difference between getting a steady pay raise every year and watching an investment suddenly go through the roof? Oh, absolutely. And it all boils down to two very powerful and very different mathematical patterns.
So here's our game plan. First, we're going to learn the basic language, the secret code, if you will. Then we'll dive into the two major patterns, one for steady steps and one for giant leaps. And finally, we'll see how you can use all of this as part of your own financial toolkit.
All right, before we can understand financial growth, we've got to speak its language. And that language really starts with just two basic ideas: sequences and series.
Okay, so what is a sequence? Well, it's not just a random jumble of numbers. It's an ordered list where every single number follows a specific, predictable rule. It's like a trail of breadcrumbs. You know, a sequence like 2, 4, 6, 8. There's a clear rule there, right? You just add 2 each time. It's logical. Now, if the sequence is the list of numbers, what's a series? It's simple. A series is just what you get when you add all of those numbers up. It's the grand total, the cumulative results of that pattern over time.
So here's the difference in a nutshell. Think of it this way. A sequence is the path. It's each individual step you take. A series is the total distance you've traveled. A really simple but super important distinction.
Okay, let's grab our first power tool from the toolkit. This is the math behind anything that's steady, predictable, and consistent. It's called an arithmetic progression, and it is all about taking those steady, reliable steps.
So, in an arithmetic progression, or AP for short, you are always, and I mean always, adding the exact same amount to get to the next number. That constant amount is called the common difference. It's linear, it's dependable, and it makes things really easy to predict.
And here's the formula that cracks the code. If you want to find any term in the sequence, you just need three things. A, which is your starting number, N, which is the position you're looking for, like the 10th or 25th spot, and D, which is that constant number you're adding every time.
Let's make this real. Imagine you start a job making 3,000 rupees a month, and you're guaranteed a raise of 100 rupees every single year. That consistent 100 rupee bump, that's your common difference, D. It's a perfect, real-world example of an arithmetic progression in action.
And the cool part is, with that formula, you don't have to count up 25 years one by one. You can calculate exactly what your monthly salary is going to be in your 25th year, 5,400 rupees. See? That's the power of predictable, steady growth.
But here's where it gets really impressive. Let's look at this series, the total sum of everything you earned. When you add up all those paychecks over 25 years, you've made over 1.2 million rupees. Those small, steady steps, yeah, they really do build up to something significant over the long run.
Okay, time for our second power tool. And this one is a game changer. If arithmetic progression was about adding, this one is all about multiplying. Welcome to geometric progression, the engine behind explosive compounding growth. This is where we go from taking steady steps to taking giant leaps.
The key here is something called the common ratio. Instead of adding a flat amount, you are multiplying by a constant factor every single time. And folks, this is where the magic happens. Because you're multiplying, the growth isn't flat. It builds on itself, getting bigger and faster with each step. This is the very heart of compounding.
Now, the formula might look kind of similar, but trust me, that tiny exponent there makes a world of difference. To find any term, you take your first term, A, and multiply it by the common ratio R raised to a power. That little exponent, that's basically the launch button for exponential growth.
To really feel the power of this, let's look at a pretty wild scenario. Imagine you take out a loan, and you agree to pay it back in 10 installments. Sounds normal, right? But here's the catch. Each payment is double the one before it. So our common ratio is 2.
Now, what's so crazy here is how harmlessly it all starts. Your first installment is just 8 rupees. I mean, that seems totally manageable, almost like a joke, right?
Your second payment is 16 rupees. Still, nothing to worry about. We're just doubling a tiny number. The danger is completely hidden in plain sight.
The third is 32 rupees. You can see the pattern, but the numbers are so small, it's so easy to be deceived by the slow start of a geometric progression.
But right about here is where things start to get interesting.
And boom, there it is, the giant leap. By the time you get to that 10th and final installment, that single payment has exploded to over 4,000 rupees. We went from a harmless 8 rupees to over 4,000 in just 10 steps. That right there is the shocking power of geometric growth.
So we've seen the steady steps, and we have definitely seen the giant leaps. But how do these two ideas actually show up as tools in the real world of finance? Well, the answer is they're literally everywhere once you know how to look for them. You know that incredible power of compound interest everyone talks about? That's pure geometric progression. It's why an investment can eventually blow that steady salary out of the water. A car losing 15% of its value each year, also a GP. But planning a recurring deposit with fixed additions or a simple interest loan, that's often a classic arithmetic progression. These aren't just theories, they are the operating systems for your money.
Look, mastering these ideas is absolutely fundamental. They really are the building blocks for all the more complex formulas you'll see in accounting and finance. Understanding them gives you this incredible power to look into the future and make much, much smarter financial decisions. So there you have it. You now have the two fundamental tools to decode the hidden patterns of growth and decay all around you. Whether you're looking at an investment, a loan, or even your own career path, you can now see the hidden math that's at play. The only question left is, now that you have the keys, what are you going to unlock?